What if I told you that there was a cooling fan that probably provides more CFM per size compared to any other fan out there, and it was available in your local junkyard? What's going on, YouTube? Levi of Old Iron Off-Road out here today hammering on this guy. Again, if you can imagine, we have actually made quite a bit of headway since you last saw this rig. We've got a windshield in it looking fancy. We've got these chopped down doors that we actually are not quite finished with, but we're actually going to make an inlay. My metal guy hooked these up. He worked them. We actually split this door. This door was pretty rough. We actually cut the whole, he cut the whole bottom out of another door, pieced this one together. So now we've got a pretty solid door. No guts, but we're going to do a cap with some bead rolling in this guy. We've got our transfer case shifters. We've got our transmission shifter. Trans tunnel cover is on. Hey, you, reach down there, hit the subscribe button. It's free. We have been moving and shaking. So today we are going to be digging into the cooling system on this guy. We've got our radiator mounts mocked up. We're going to build a fan shroud. We're going to get the radiator hoses in. I actually did a short on how we figure out molded coolant hoses for our custom builds. So if you're struggling with trying to find a formed hose off-the-shelf part that you would like to use for your build instead of one of those janky little universal flexi dealios, jump over there and check that out. I actually leave a link to that short in the description as well, so you can scope that out. But yeah, like I said, today we're going to be digging into the cooling system. We're going to build a shroud, install our cooling fan, get our heater box in, get all that plumbed, and man, we're getting it. Let's jump into it. So an issue that you see a lot in custom builds is people don't plan for a proper cooling system. Cooling system in a custom application can be an intricate and important part of your build. Obviously, if you've got a high horsepower V8, you're going to need large cooling capacity, you're going to need a good radiator, and you're going to need a good way of supplying airflow, be it a big mechanical fan or an electric fan. Pick your poison. Now, another thing we'll talk briefly about is going to be fan shroud design and or lack of fan shroud. A fan shroud can also be a very important part of a cooling system. If you don't have a fan shroud, you're giving up a lot of potential airflow across your core because air is just being kind of moved around and not drawn directly through your radiator. Now that can be said for mechanical fan or electric fan. A lot of guys build fan shrouds for electric fans, and what actually ends up happening is at idle you will properly cool, but moving down the road you lose cooling efficiency and you end up overheating, even though you may or may not have a properly rated size fan. But the main reason that you see overheating issues when you're running down the road is simply due to lack of airflow. Now, for the majority of builds out there, your fan really shouldn't be working hard when you're running at highway speeds. Moving at 50, 60 miles an hour, there should be enough air moving across your core that the vehicle should stay cool. But what happens with an improperly designed fan shroud is you inhibit that ability for air to move across the core. It basically just hits a wall when it's trying to come across your radiator. So we'll talk some about that. Let's talk about fan choices specifically. Mechanical fans versus electric fans. Mechanical fans are great if you can use an OE style fan with your engine. If you can use an OE fan with whatever engine choice you're using, chances are that fan should be rated to move enough air to keep your engine cool. Now, obviously in the world of engine swaps, that's not always possible because you don't have the necessary amount of room to fit mechanical fan. Enter the electric fan. Now, a huge misconception or a huge problem with thought process on electric fans that I see are that all electric fans are created equal. An electric fan is an electric fan. You put a big 17-inch electric fan and it should move all the hairs, and that's simply not true. Obviously, most people that are in this position to install electric fans should consider or at least have an idea of CFM. And cheap fans just aren't rated. You might have a huge 17-inch fan, but it might only pull 1,300 CFM of air, and that's not enough to keep anything cool. There's some charts online, and I think a moderately built V8 requires somewhere around 26 to 2,800 CFM to keep the engine cool, and that is also taking into consideration the cooling system itself. The radiator, is it big enough? Is it a cross flow? Is it a down flow? There are lots of things to be considered in this equation. Now, me in particular, with this being a rock crawler, and this is another thing to consider with mechanical versus electric. This thing is going to spend a large part of its life crawling around at low speeds. And a mechanical fan and low speeds don't really lend themselves to properly cooling an engine. Your fan's not spinning fast, you don't have any forced airflow across the face of the radiator, so you can end up with overheating problems. Now, are there people that crawl with mechanical fans and they work fine? Absolutely. Yogi in particular has a factory LS or a factory Silverado 2500 truck fan on it, and it cools great. But on this one, with it being more of a dedicated crawler, we wanted to go with an electric fan. Now, what if I told you that there was a cooling fan that probably provides more CFM per size compared to any other fan out there, and it was available in your local junkyard? There is. This fan literally blows the competition away, or sucks. Yeah, it's a puller. It doesn't blow. It sucks. You get the point. So this fan actually came in a couple of different model vehicles, and the model of vehicle that this fan came in is going to determine your ease of installation. Now, this fan in particular, the fan portion itself, was installed in Ford Tauruses in the mid-90s, and also was in several Volvos in that era. Now, this fan in particular was out of a Volvo, I think a 970, and the benefit of having the Volvo fan over the Taurus fan is the Volvo is kind of modular in that it doesn't have a huge shroud attached to it that you have to hack up to make the fan fit. Now, the fan itself, this thing, I can't remember what I saw. Somebody said that this thing can move like 4,000 CFM of air. It's ridiculous. This thing moves a ton of air. Not only does this fan move a ton of air, if you look on the interwebs, you can actually find its own controller, and you can see that this is a Volvo fan controller, and I think they use the same controller on the Tauruses. Now, the beautiful thing about this controller is it is its own relay, and it is already set up for a low and a high speed control. If you're running fuel injection, kick your low speed to one side, kick your high speed to the other, set your temps, bada boom, bada bing, you've got a really killer high CFM, low and high speed fan. And even if you're more old school, you can actually run two coolant switches on your intake into coolant passages, and you can still trigger the low and high side, or you can just wire them together to come on at the same time. Or I can't remember if you just wire the high side or you wire them both together. Anywho's, this thing is cool. And this controller is actually available new still. So I got this one off of eBay because it had the connectors, and I actually got another one of these for a spare for the rig. Now, the only real downfall to this fan is you can see that it is sort of chunky, and it does protrude outside of this surface. So your shroud has to be boxed away from your radiator, or this will actually set flat against the core when you try to mount it up. So, without further ado, we're going to dig into this. We're going to build a shroud for this dude. We're going to get it fit up on our radiator, and we're going to get it mounted in our rig. And we're going to have all the cooling capacities that we should ever need for this rig. Let's get into it. So, first things first, I am pretty positive that we've got room for this guy. I've kind of loosely fitted in there, but I want to look and see roughly where we're going to try to mount this guy up. And I think we're actually going to have to push it push it real good. We're gonna have to push this guy towards the driver's side of the radiator a bit to get it to clear our wastegate. So we're actually gonna run this shroud about an inch off of the radiator. That should give us plenty of room. So get this radiator pulled out and start building the shroud. Did I tighten those down? No. Oh man, I'm ready for this thing to be running. Ready to fire her up, boys. Little radiator mount that we built. So we are going to set this dude about an inch off. And here you can kind of see what I was talking about how much that fan actually protrudes outside of the mounting flange. I mean, we're a good inch off of the face of the cardboard. And I'd like to give it a little bit more, so we're probably going to raise that guy up just a shade more. And that is actually kind of an important thing. You don't want the fan pushed just completely slap up against the radiator. You would like a bit of room between the core and the actual blades of the fan. So we're going to space that guy up about like that. Should be able to make something to do with that. All right. So we got to figure out what exactly we're doing with our lives, and we're going to have to do some drawing, get it figured out. Let's get it. So we're going to figure out some basic dimensions here, kind of get us an idea of what we need to make happen. I think that's an inch. This always makes me nervous because if there's any flex in the shroud, this little dude out here will get into the core. That's the only downfall with these fans. I've got a piece of 3/16. I'm gonna come off of that another 3/16 and see where we're roughly at. An inch. Man, it says an inch is good. I mean, that's going to give us about a ½ inch of clearance. Should be plenty. All right, inch it is. So. So you can see what we've done here. These are actually air holes. This is so air can flow across the core. I've actually ordered some, they make flaps that you drill a couple of holes and a flap will actually cover that. So when this is creating a suction or a vacuum, it'll pull the flap closed. But when you're running down the road, the flap can actually blow open and allow airflow across the core. Those will be here in a few days. So for now, I think the next step is to actually drill the shroud, get the fan bolted to it, and I can cut some pieces and actually TIG weld them to close off that side and this side, and add some rigidity to this guy, and then we can actually get it bolted to the radiator. I dig it. All right, so real quick, we cut us a couple of little filler pieces here to TIG weld in on the edges. Again, it's gonna add some rigidity to this shroud and help seal off some of the air. You wanna try to seal off the sides. You basically want to try to channel as much air across the core as you can. And if these sides are open, it's just gonna let air suck in from the sides instead of moving across the core. So, clean your aluminum better than I clean mine. And I guess we're going to find out what kind of aluminum welding day today is going to be. Whether it's going to be a good day or whether I'm going to be upset. So let's make that happen. We got the shroud all welded up. That should do its job. And now I think we can actually fit the fan to the shroud, get it bolted up. We're making headway on the cooling system here. I always bolt mine in from the back side. That way the stud side is actually protruding towards the front. Yeah, boy. She's gonna be good pretty soon. She'll be like, what, pal? Whip you. And one nasty cooling fan and a custom shroud. I dig it. Now we're gonna get this guy mounted up to the radiator. We can actually mount the radiator up and mount up our radiator hoses. I will be 100% honest and say that I'm not a huge fan of the flange on Griffin radiators to mount the shroud to. They offer, it's just a little bitty shroud, it's just a little bitty flange, And usually I end up using number 10 machine screws to mount it. You can use self-tappers. You can drill straight through this support. It's basically a tank support that goes between the tanks. You can use self-tappers if you want. I've drilled and tapped this for 1032. I've used a nut. There's several different ways you can do it. Again, I'm not a huge fan of how small of a mounting surface it is. It doesn't leave much room for air. Now, drilling through this, you don't have to worry about it. Your actual core starts here. There's nothing but fins, so you don't have to worry about hitting anything here, but all the same. Oh, still got plenty of clearance. Oh yeah, that's gonna work out nice. Got a little bit of a gap, but it's okay. Yeah, we use machine screws and nuts on this guy. I'm gonna slide that over just a bit. Make sure I have clearance for my radiator hose around this, and I think that's good. All right, hopefully this works out. I hope I've got enough meat on the back side of this for a nut. Don't have to be, we do. But man, it's gonna be tight. I don't know what's a good way to do this other than just to send it. So I'm just gonna send it. Just gonna send it. Got enough there. And we are actually going to use a measuring tape here, believe it or not. Or not. I don't know what I did with it. So I think it's time to get our coolant hoses fit up. And I think I mentioned earlier in the video, we are running molded coolant hoses. And I actually did a little short video to show you how exactly I come up with off-the-shelf molded hoses that you can use too with your custom application. I will leave a link to that video down in the description. Perfect. It's perfect. It's perfect. It's perfect. Take another inch off of that, get it off of it. We're gonna have to reclock the water neck just a shade, pretty much bring it straight. So. For a molded hose, that fits in there perfect. We're able to zigzag around that. Good. Always make sure you write your part numbers down somewhere as well. You can try to leave the tag on the hose, but it's not going to stay. I actually put stuff like this. As we've been building this guy, we've actually already started a spare parts bag. And as you can see, got V-belt part numbers that we're running. And you could throw these in there as well, which I probably will. Or you can jot down your part numbers on one of your belt packages. So we'll throw those in there too, just in case. It won't hurt anything to have extras. That way, no matter where we are, we at least have the part number that we need. Whether or not the parts store will be able to get it, that's a different story. So before we got too deep in putting the heater in, I thought I'd take a couple of seconds, power this thing up, make sure that my controller was good, and show you how easy it is to wire this thing, and also show you how much air this thing actually moves. We'll turn on the low side first, and that should be low. That's low. And you can see this dude is moving the airs. And then on the high side, so yeah, that is a killer budget-friendly fan if you're looking for something for your custom application and have the room to fit it. The Volvo or Ford Taurus fan works really well. So now let's jump into the heater install. What's going on? Another day out here in the shop trying to get a few things buttoned up. The flaps for the fan that I mentioned actually came in, pulled the fan out of the truck and got those modified. I'll flip you around. These will suck shut when the fan comes on and actually help seal off any, basically seal these ports off. When you're running down the road, the fan shouldn't be on anyway because you should have enough air moving over the core of the radiator to keep the engine temps down. These will actually blow open and allow for proper airflow across the core. We've got our heater here, and what we're actually doing is we're adapting from these vents. We're actually adapting these so that we can run some defrost vents because we have to hook up these guys. I'm actually wanting to use these vents in the console. And then we've got the piece of defrost tubing here that we're gonna be using. So trying to make that happen. Pretty much have this figured out. I've just got to epoxy these in. We should be good to go. So yeah, I'm gonna put you down and we're gonna make some stuff happen. Well, that should serve its purpose. And because I reduced the size of the hole that the air would normally be able to blow through, this is only 1.5 inches fitting. I went ahead and drilled a couple of holes in the face of this plate. That way it wouldn't put in any unnecessary strain on the fan. So it should be able to kind of move as much air as it was before. So basically what we've done here is we've got feet warmers, and we've got our other comfort settings. We've got defrost, and we've got all the airs blowing on us. So a couple of other things I'm gonna have to do while that epoxy is drying. I have this big chunky heater valve that I'm not super thrilled with just because it is so bulky, but I think the benefit of having it's gonna be worth the ugliness of it. This is just a manual bypass style heater valve, and I don't want coolant circulating into the cab if I don't need it. So in the summertime, there's not going to be unnecessary heat flowing into the heater box and making it hot in the cab. So wintertime, we crack this guy open, we've got heat. Summertime, shut it. You don't have any extra heat soak coming into the cab. I've got these bulkhead fittings that I need to install in the firewall, and we've got these nice coolant hoses. So I think now we'll get the heater valve put in and we'll go ahead and continue plumbing from here. These are our 2 heater ports, and yes, I think we mentioned before, this is a water-cooled turbo, so we're tied into the cooling system there. And I'm gonna try to stash the heater valve somewhere here out of the way where you don't really see it, and then we'll put the bulkhead fittings somewhere in this general vicinity here. So we got that guy in there, not super pretty, but functional and should help keep some heat out of the cab. And I do like it because it's a bypass, so coolant can actually circulate through that even when the valve is shut, so that's good. Hopefully our epoxy is dry-ish, and we should be able to kind of, I know it's gonna set somewhere in this vicinity. This bracket's a flat mount and we need it to kind of kick out a little bit so that our defrost ducts or our ducts don't crash into the transom cover. So I may just cut a new bracket, or I may cut that one up and modify it. I'll get it over here and play with it and see what needs to happen. Something along these lines is what's gonna happen. And maybe you can see me over there, but these molded 90-degree hoses should really help make that hard transition and not kink our hose. So this bracket is, like I said, flat, and we need some kind of an angle on the dangle. And I think probably the easiest thing to do is just going to be to cut this bracket and add some pieces to it and make it work. So let me get I don't want to block this fuse. I don't want to keep that kind of open. But yeah, should be pretty, hopefully it should be pretty straightforward. Get a measuring tape over here and measure out what kind of pieces I need to make. So yeah, I think that's going to do what we want it to do. Going to actually take 2 of these and sweep them right up into the back of these vents, and this other one can get routed up into there, and we'll be in good shape. So I am going to throw these hoses on real quick, and again, you can see the 90-degree molded coolant hoses should make that pretty reasonably. Should make it pretty nice where there's not like a hardcore bend or a kink in there. We'll have to trim the top part back just a bit, but I like it. Yeah, that worked out pretty well. Cut that one a little short, but it's all right. Looks good. All right, so the cooling system in this guy is effectively finished. If we wanted to, we could put some coolant in this guy. I think on the next video, we're gonna dig into the fuel system on this guy. We're gonna get the in-tank pump stuff set up. We're gonna get the Holley hydromat in there. We're gonna get the fuel lines ran, regulator mounted, and all that good stuff. And then that can lead us into the fuel injection. And we shifted gears on the fuel injection, and we are actually running a Holley Terminator Stealth. So we will be doing a full install video on that, and I'm going to take you through some of the basic tuning on this guy, which it's going to be a little bit of a learning curve because I've never tuned anything for boost. We are going to do boost control. We're going to set up some MAC valves and a dome pressure sensor and all that good stuff. Luckily, I've got a friend that's local that has done a couple of forced induction drag cars that he's pretty savvy with setting up Holley stuff for boost. So I think that's all we've got for this video. I appreciate you guys and gals at home for taking the time to watch these videos. Thanks for watching. Make sure to like, comment, and subscribe. And as always, enjoy.